Greek mathematics developed from the 6th century BC to the 5th century AD around the source of the Mediterranean, and constitutes a major period of the history of mathematics, fundamental in respect of geometry and the idea of formal proof. The word mathematics itself derives from the ancient Greek mathema, meaning subject of instruction.
Greek mathematics also contributed importantly to ideas on number theory, mathematical analysis, applied mathematics, and approaches close to integral calculus. Greek mathematics has origins that are presumed to go back to the 5th century BC, but are not easily documented. It is generally believed that it built on the computational methods of early Babylonian and Egyptian mathematics, and it may well have had Phoenician influences. The ancient Greek numeral system, known as Attic or Herodianic numerals, was fully developed by about 450 BC. It was a base 10 system similar to earlier Egyptian one, and even more similar to the later Roman system, with symbols for 1, 5, 10, 15, 100, 500, and 1000. Repeated as many times needed to present the desired number.
Most of Greek mathematics was based on geometry. Thales, one of the 7 sages of ancient Greece, who lived on the Ionian coast of Asia Minor in the first half of 6th century BC, is usually considered to have been the first laid down guidelines for the abstract development of geometry. Although what we know for his work, such as on similar and right triangles, now seems quite elementary. Thales established what has become known as Thales' theorem. He also credited with another theorem, also known as Thales' theorem or the intercept theorem. According to some historical sources, the Greek mathematician Thales applied the intercept theorem to determine the height of the Cheops pyramid.
The intercept theorem can be used to determine a distance that cannot be measured directly, such as the width of a river or a lake, the height of tall buildings or similar. Pythagoras was an Ionian mathematician and philosopher, known best for the Pythagorean theorem which bears his name. Pythagoras' followers were commonly called Pythagoreans. For the most part, we remember them as philosophical mathematicians who had an influence on the beginning of axiomatic geometry, which after 200 years of development was written down by Euclides in the Elements.
Hippocrates of Chios was an ancient Greek mathematician, geometer and astronomer who lived from 417 to 410 BC.
The major accomplishment of Hippocrates is that he was the first to write a systematically organized geometry textbook called Elements, Στοιχεία, that is basic theorems or building blocks of mathematical theory. From then on, mathematicians from all over the ancient world could, at least in principle, build on a common framework of basic concepts, methods, and theorems which stimulated the scientific progress of mathematics. In the century after Hippocrates, at least 4 other mathematicians wrote their own elements, steadily improving terminology and logical structure. In this way, Hippocrates' pioneering work laid the foundation for Euclides' Elements, that was to remain the standard geometry textbook for many centuries. Hippocrates worked on the classical problems of squaring the circle and duplicating the cube.
Hippocrates also invented the technique of reduction, that is to transform specific mathematical problems into a more general problem that is more easy to solve. The solution to the more general problem then automatically gives a solution to the original problem.
Euclides was a great Greek mathematician. Although little is known about his early and personal life, he went on to contribute greatly in the field of mathematics and became known as the father of geometry. Euclides is known to have taught mathematics in ancient Egypt during the reign of Ptolemy I. He wrote Elements, the most influential mathematical works of all time, which served as the main textbook for teaching mathematics from its publication until the late 19th or early 20th century.
Elements aroused interest of the Western world and mathematicians around the globe for 2,000 years. Euclides used the synthetic approach towards producing his theorems, definitions, and axioms.
Apart from being a tutor at the Alexandria Library, Euclides coined and structured the different elements of mathematics such as porisms, geometric systems, infinite values, factorizations, and the congruence of shapes that went on to contour Euclidean geometry. His works were heavily influenced by Pythagoras, Aristoteles, Eudoxus, and Thales. Hypatia of Alexandria was a philosopher, mathematician, and teacher who lived in Alexandria, then a Greek city. Several works are attributed to her by later sources, including commentaries on Diophantus Arithmetica, on Apollonius Conics, and on Ptolemy's works, but none has survived. Eratosthenes was a Greek mathematician, geographer, poet, astronomer, and music theorist. He was a man of learning, becoming the chief librarian at the Library of Alexandria. He invented the discipline of geography, including the terminology used today. He is best known for being the first person to calculate the circumference of the Earth, which he did by applying a measuring system using stadia, a standard unit of measure during that time period. His calculation was remarkably accurate.
He was also the first to calculate the tilt of the Earth's axis. He may have accurately calculated the distance from the Earth to the Sun. He created the first map of the world, incorporating parallels and meridians based on the available geographic knowledge of his era.
Diophantus of Alexandria, sometimes called the father of algebra. He was a Greek mathematician. He is the author of a series of classical mathematical books called the Arithmetica and worked with equations which we now call Diophany equations. The method to solve those problems is now called Diophanous analysis. Hipparchus was a Greek astronomer, geographer, and mathematician. He was born in Nyssa and probably died on the island of Rhodes. He was the first Greek to develop quantitative, accurate models for the motion of the sun and moon.